scattering of light means earlier we discussed about that whenever the sunlight is traveling into the droplets, water droplets after the rain, then the light will be dispersed and it will form the rainbow. And as well as here when the light is traveling in the earth atmosphere, when the smaller objects means dust particles in the atmosphere, earth atmosphere, dust particles like that, when the air molecules are obstacle means sunlight is whenever passing through the atmosphere, due to that particles the light can be absorbed by that particles and that will move into the all directions. That means to say the absorption of light molecules is traveled into the all directions is called scattering of light. In other case we can say like scattering of light means when the particles are in the way of light, then that particles will changes the direction of the light, means the direction of the light changes is called as a scattering. Here also we are going to discuss about that scattering of light. In that scattering of light, Rayleigh has given some of the equations about the scattering, as well as we are going to know that why the sky is blue, why the sky appears blue whenever we see that the why the sky is appears blue, because of here the scattering of light. Scattering of light means when the light ray is instant on small particles, it is absorbed by that particles, and this absorption of light is then sends into the all directions is called scattering. Is called scattering means when the sunlight is traveling through the any particles and the light will changes its direction is called also angle of scattering. So here the Rayleigh has given an equation, the blues of the sky means whenever the sky appears blue, and as well as at the time of sunrise and sunset, and the sun appears whenever he is at a horizon, then it appears red, sun appears red due to the scattering of light also. Here we can say that the light will scatter in all the wavelengths of light can be scattered. For the short wavelength of light waves means the short wavelength of light can scatter more than the more wavelength of light, like the lights will more scatter than the red light. Red is having more wavelength, so that's why the total lights means colors, diffusion colors is there. Whenever the light disperse, then several colors will be emitted from that, emerged that. So that's why that red color is having more wavelength than other colors. So that's why in that case short waves means short wavelength waves can be scattered more than the long wavelength colors. Here is that what Rayleigh has actually said about the scattering means Rayleigh scattering. What is meant by the Rayleigh scattering means the scattering is whenever the particles are instant on that some of the particles, when the light is instant on the some of the particles, then light will be scattered like this. Even in case of when the light is instant on the some of the particles, this will be scattered and this will also changes the direction, this is also scattered. Here is that which is having that more wavelength was less scattered. This is a less wavelength or more scattered. Like that, Rayleigh said that the scattering is inversely proportional to the fourth power of its wavelength. Means here the scattering, how much its scattering will be possible means is inversely proportional to the 1 by fourth power of, means inversely proportional to the fourth power of its wavelength. Means if the wavelength is more, scattering will be less. If the wavelength is less, scattering will be more. Like that, here whenever the light is emitted from the sunlight is traveling into the air particles, air molecules, then some of the colors will be disappeared, means emerged. This formula is called as a Rayleigh scattering formula. Here is that why the blue appears, why the sky appears blue. Actually we can see whenever we see this we see the sky, that means appears blue. At the time this, according to this law, the light of short waves, according to the Rayleigh, the light of short waves that is like violet, green, yellow, blue, that type of colors means violet, yellow, green, blue. This type of low wavelength means less wavelength of light than the, if we compare with the another more wavelengths in that case. So they can more scattered about the 10 times than the more wavelength like red light. Means if the red light is scattering, then more 10 times more than the red light, these colors will be scattered when it is there traveling in the earth atmosphere. When according to this law, the light of short waves, that is violet, is scattered about 10 times as the longer waves of red light. Means red light is having more wavelength than the other wavelength. So that's why already earlier we told that when in traffic signals also we use the red light for the stopping signal, because of red color is having more wavelength. So that's why red color is used for the stopping wave in traffic signals like that. Here remaining colors which is having the blue, yellow, green, violet, these are colors are having the less wavelength than the red color. So that's why here that colors will be more scattered than the red color. So that's why here when the sunlight enters the earth atmosphere, violet and blue light are scattered the most. Violet and blue light can scatter the most, followed by the green, yellow, orange, red. Followed by the green, yellow, orange, red. When the sunlight is traveling, all the wavelengths can be traveled same. But these two colors, blue, violet, is having less wavelength. Means violet is less wavelength than the blue color. So that's why more dispersed, more scattered. Then here violet can be seen. Our eyes are sensitive for the violet. So that's why the sky can be appears blue for us. So here at the noon time on the clear day, when the sun directly overhead and illustrated by the observer, the whole sky appears light blue. This is the composite colors of a mixture of colors. This is not only blue, this is a composite color of mixture of blue, yellow, violet, green. Means scattered the most effectively by the air molecules. Because of here also we can say that according to the Rayleigh, the scattering is inversely proportional to the fourth power of its wavelength. That means to say, what are the colors which are having the less wavelength will be more scattered, if in case the more wavelength will be less scattered according to the Rayleigh. In that case, the size of the scatterer and the wavelengths are relative together. Means the size of the scatterers can be taken as the size of the scatterer and the wavelengths of the light. The wavelength of the light both will be 10. That is the size of the scatterer can be taken as A is relative to wavelength lambda. So here it is that when the A is less than lambda, means when the scatterers means particles are which is having the small particles than the wavelength, then be that Rayleigh is valid. Rayleigh scattering is valid. Means here when according to the scattering is inversely proportional to the 1 by lambda power 4, if in case of the scattering particles are very less small in size than the wavelength, so that's why the total Rayleigh scattering can be valid according to this formula. If in case of like air particles which are having that dust particles are large particles, means whenever the wavelengths more than the dust particles and air in water particles in the after the rain, water droplets like that particles. If in case of the droplets are more greater than lambda, this is a Rayleigh scattering is not valid. In this case of all wavelengths are scattered equally. In any case, without changing energy from the scattered to the whenever the light, if without exchange of energy, there is no change in wavelength. It does not undergo in change in wavelength unless the energy exchanges from the whenever during the collision. Otherwise, if due to, so that here is the scattering is inversely proportional to the lambda power 4. When the more wavelength means more energy, then frequency will be less. Means if the frequency is more, then wavelength will be less. Here we can say that if frequency of light frequency is more, wavelength will be less. Wavelength is less. Yes, if in case of frequency is less, then wavelength is more. Then here that the red light having the frequency less frequency, though that's why that is having more wavelength. The remaining colors which are having that frequency is more, so that's why wavelength is less. So that's why they scattered easily. They scattered more than the red color. Whenever the light ray is traveling and whenever it collide with the air particles, that will be scattered in all the directions, like this, according to this, like this, in all the directions the light can be scattered. The less wavelength colors can be scattered more, means less wavelength scattered when frequency is less, so that's why they were more, and more wavelength colors will be scattered less. This is also caused by the sun appears red at the horizon. This is about why the sky is appears blue, and the scattering of light, and the Rayleigh scattering formula. Scattering of light. When the light is passing through the atmosphere, when the air particles or air molecules through this, that is absorbed, light is absorbed by that particles, and that light sends into the all directions is called as a scattering of light, or changes the direction of light, that molecules changes the direction of light is called as a scattering of light. And also we discussed about that Rayleigh scattering, that is the scattering is inversely proportional to the fourth power of its wavelength, means longer wavelengths colors are least scattered, and the less wavelength colors are more scattered according to this. So already we discussed about the why sky appears blue, because of blue and some other related colors are having yellow, green, violet, or less wavelengths, so that's why they will scattered more, so sky appears blue. Next, in that case, according to the another application of scattering of light, the sun appears red at the horizon, means at the time of sunrise and at the time of sunset, sun appears red because of scattering of light. Because when sun appears red at sunrise and sunset, because of at the time of sunrise or sunset, the light rays, sunlight is traveling through the atmosphere in a longer distances, means this is considered the earth observer is at this place, that sun near the horizon, means it is not came to upward, so it is near to horizon. Whenever the light is traveled, sunlight is traveling to the longer distances, of atmospheres, then it appears to that the least wavelength colors which is having blue, yellow, violet, green will be scattered due to the air particles are present in the atmosphere, and the more wavelength color, that is red, will travel through the atmosphere, so that's why, and it appears to our eye, observer's eye. So that's why here the less colors due to that place, here the sun rays have to pass through the larger distances in the atmosphere. Most of the blue and other short wavelengths are scattered, removed by scattering, and the least scattered light reaching our eye, that is least scattering color is red. So among the all colors, red having more wavelength and least scattered. So that's why that least scattered color can reach to our eye. So that therefore the sun looks reddish. This explains the reddish appearance of a sun at the time of sunrise and sunset. So that another thing also, according to the Rayleigh also, we can say that as a lambda b is less than lambda, means here the wavelength of the blue color is less than wavelength of red. So that's why here the intensity of scattered light is proportional to 1 by lambda power r. So that also sun appears red, because when the sun light is traveling through the distances, this is the distance through the sunlight traveling at the earth atmosphere, means the distance of atmosphere through the sunlight traveling to this place, this is the distance. So that's why sun appears red at sunrise and sunset. Once again, sunrise and sunset. Why the sun appears at the time of sunrise sunset, means when the light, according to the colors Rayleigh method, the longer wavelength, means longer wavelength colors least scattered, and smaller less wavelength colors can be wavelength can be more scattered. So in that case, the blue and related green, yellow, violet colors can be removed due to the scattering of Earth atmosphere. Whenever the sunlight is traveling in the Earth atmosphere due to the particles, then the atmosphere molecule particles, the least wavelength will be more scattered. So that's why they are removed by the scattering, so that the least scattered color is red, that appears, the least scattered color red appears to our eye, which is not least scattered. So that's why the sunrise, at the time of sunrise and sunset, sun appears red. This is the about the one of the phenomena of due to the scattering of light, this phenomena is also applied.